Hello everyone, in this video we're going to discuss buoyant force. So the buoyant force is the force that you feel when you're in the water pushing you upwards. And it equals the density of the fluid that you're in, the volume that you displace, and the gravity. And so let's say we had a cup of water, or just some fluid, and there was a ball inside. So this ball is going to feel force due to gravity, because obviously gravity is acting on it, and also this force buoyant. So in this case, the volume of the fluid that this ball is displacing is equal just to the volume of the ball, because all of it's in the water, or whatever fluid it is. But now let's say we had another scenario where the ball is floating at the top here. Now there's still some gravitational force on this ball here, and there's still buoyant force, because otherwise, without the buoyant force, the ball would just be falling through, but the buoyant force keeps it at the top. But in this case, there is still some volume that's displaced from the water, but it's less than the full volume of the ball, because only about half of it looks like, in this case, is being displaced. So when you're using this volume right here, you want to make sure that you use the volume that's actually being displaced by the object, not just the volume of the object. Unless the whole thing is submerged, then you can use the whole volume. Okay, so let's look at an example. So a marble is placed in a cup of water. The water is then poured out and replaced with a liquid that is 1/3 as dense as the water. The marble remains at the bottom of the cup. Compare the buoyant forces so that the marble fell in each scenario. So let's say we have a cup here, right, and there's a marble at the bottom. And then we have a second cup, and scenario 2 where the marble is still at the bottom. Now, the first one, we just have water, which we can call a density of rho, and then we pour it out, and the liquid is 1/3 as dense as water. So in this case, we can say it's 1/3 rho. So we know that the buoyant force equals the density of the fluid, the volume times the gravity. Okay, now in this case, since the marble is fully submerged, the volume that's being displaced is equal to the volume of the ball. So we can just use volume of the ball. Okay, and since it's fully submerged, it's not going to change between the two scenarios. So let's write a formula for the first scenario. We'll just say force 1 is the density times the volume times gravity. And now when we replace the fluid with the 1/3 density fluid for force 2, we get 1/3 the density, volume, gravity. And since these variables right here are not changing, we can say that the force 2 that is felt is 1/3 the force that is felt in the first scenario. And so that's what we get. So we would have in both these scenarios a force due to gravity and a buoyant force. And in this one, there's less buoyant force, and there'll be less buoyant force. And then so obviously, since the marble's standing on the ground, there's also going to be a normal force, because the forces have to balance since the object is not moving and it's not going through the container. Okay, so that was about buoyant force. Make sure to leave your questions down below, and thanks for watching.